So, good afternoon. Today we came to our plumbing class day. Uh, so today, we will be dealing with some of the topics. And last day we were dealing with this pump selection, uh, criteria for pump selection, etc. Not only that, we have studied about different ways to reduce the pressure in the high-rise building. So we were dealing with the pressure valve system, or pressure reducer valve system, then brake pressure tank system, and the intermediate tank system, etc. Like that. So we were dealing with that. So today what we are going to do is that uh, we'll be dealing with another topic that is water management system. Okay, water management system. It's a very easy topic only. We'll be solving a problem today. Not only that, we'll be dealing with different pre-treatment requirements. Like usually when we get a project, what we do or what we have to do is that uh, you know from the underground tank or from the well, you have to pump it to the overhead tank. So it is not necessary that always the water is pure. Okay, it is healthy for drinking. It is not always the same. Okay, in every cases. So what we do is that we'll be having an addition or a filtration system. A pre-filtration system is there. So when we are pumping to the overhead tank, the water will be circulated through the purification system, and then only it will be reaching the overhead tank. So where it is not necessary that the purification plant should be kept after the pump uh, or in the line between the underground tank and the overhead tank. We can keep the filtration system after the overhead tank also. Okay, the two way you can place it. One is while you are pumping from the underground or from the well to the overhead tank, you can place the filtration system in between that, or you can place after that also. You can place the filtration system after coming out from the overhead tank before it reaches to the other different fixtures. Okay, for drinking purpose like that. So what we use is that we have different types of pre-filtration systems are there, or pre-treatment systems are there, and we will be checking the water. We will be testing the water, and we will be checking whether there is an iron content or some other impurities are there or not. Depending upon the condition of the water, we will be selecting the uh, you know we'll be selecting the filtration that we do. Some days we may use sand filter, or we may use carbon filter, or we may use iron filters, or nowadays all these three are incorporated in a single filter also. That is also available. Okay. Then we have RO filters are there, UV filters are there. Just if you want just a softener, that softeners are there. Okay, and then filters are there. So the different types of filters are available in the market depending upon the application and the filtration system is a must. In the case if the water is not pure. Okay, so we'll be setting a filtration system. Okay, after the pump connection, and this will be circulated through the filter, and then at last it will reach the overhead tank. From the overhead tank, it will be supplied to individual fixtures. So that's what I have already said, that we can keep the filter between the underground tank and the overhead tank, or between overhead tank and the fixtures. Anyway, you can just keep it. Okay, and yeah, that is about pre-treatment. Okay, that is about pre-treatment system. So this treatment is very important. Like in some cases, the client may say that they don't want any pre-filtration system because they say that their well water is pure. Okay, and if needed, okay, they use a small purification for drinking, like AquaGuard, etc. So you know what is AquaGuard? That's a small purification system for drinking purpose. So sometimes they will be saying that we need only a purification system in our kitchen, like aquaguard, like that, for drinking purpose. In some other cases, in majority of the cases, we have to give the filtration system, and we have to know what is the flow through the filter. Okay, which liter per second we have to circulate it. Okay, that is the main thing that we need to know about the filtration system. So if you are writing, you can just write. I will just explain pre-filtration treatment. There are different. If you want to note it down, you can just note it down. What are the major or the main, filters? There are n number of filters, but main filters. What are the main filters that we can just see it? So, the heading is water management system. Okay. So the heading is water management system, and yes, share my screen. The heading is water management system. Okay, so yeah, like for example, this might be the building, and these are the different water systems that they have given. Okay, we don't want to study all these things. Like we'll be having RO plant. If you want RO plant, we have RO plant. If you want softeners, we have softeners. Okay, and then this is STP, sewage treatment plant, hydrodynamic systems. Okay, uh, flush water ring system, hot water return pipe. These are different, water connections. Okay, water management systems. Like we have hot water system, we have cold water system, we have flushing we have flushing. Then if we need for HVAC, we need pumps. Like if you are using chillers, so that also you need. Then filtration system, different filtration systems are there, like RO plants, softeners, dual media filter, etc. Then we'll be having storage tank. The water will be reaching through gravity, or we can use hydrodynamic system. Hydrodynamic system, we can direct. We have seen yesterday direct as well as indirect supply. So direct supply means direct by the help of a pump. Directly we are supplying it to the fixtures directly, not going to the overhead tank but coming back. We are directly pumping it. Okay, so there are different. So mainly in this water management system, we have to mainly focus on this different types of supplies, like main water supply, then raw water, or which means that we can say as fresh water, uh, and fresh water. Okay, fresh water is there, fresh water is there, hot water is there. Okay, then chilled water is there. Okay, all those things comes in this water management system. Then direct supply of water is there, as well as indirect supply of water is there. Indirect in the sense the water will be pumped to the overhead tank, overhead tank. Then from the overhead tank, it will be given to the individual, floors. Okay. Then we have purification system like RO plant. Okay. So we'll be using different softeners. Okay. Dual media filters we might be using it, and then RO plant, dual media filter plant, softeners we'll be using. These are the different ways that you know uh, we will be we'll be finding out the we'll be dealing with the water management system. Okay. Now, so like just I will show you different types of I will show you different types of purification system. Uh, you can see this. This is the main type of that we see usually pre-treatment. This might be like a sand filter or a iron filter or a carbon filter, etc. like that. So from the underground tank, it will be pumped and it will be circulated, okay, through this. So one might be sand filter and other might be carbon filter also. or one might be the iron filter, or other might be sand filter. It can be anything depending upon the requirement or depending upon the water that we have to treat. Okay, so there will be pressure valves and all those things. So it will be entering in the one motion, it will be circulating and it will be coming, okay, through the other end. Okay, so this is one of the filters. Then then we have three different types of filters that they are dual media filters. We have softeners and we have RO system also. Okay, just we know all these things, but for your idea, just I will give a brief idea about this. What is the dual media filter? Filtration is also an important treatment step in water purification system. The units consist of, so what things is present inside the dual media filter. So there are different types of filters, in which one type is a dual media filter. So what are the things which is present in the dual media filter for purification of water? This the unit consists of quartz sand, pebbles, and activated carbon. Okay, so these are the main materials that is present in the dual media filter. One is, it consists of a quartz sand, then pebbles, and then activated carbon. So this helps for purification. Okay. Then where it is being used, dual media filter, where it is being used, or what is the application? Uh, Main thing is that color and order by using this dual media filter. Even the order can be removed, or the smell can be removed. Okay? And the color also can be removed. Then suspended solid, organic and inorganics removed for water. So uh, these suspended solids, organics as well as inorganics, is being removed from the water by the help of dual media filter. Now then, let's think like we use softeners also. We use softeners also as a cleansing medium or a purification system, in which its color and order. Here also, by using softener, the color and order can be removed. Suspended solids, organic and inorganic particles are also removed. Okay, and where this is applicable is, it is applicable in bathing and laundry, boiler, cooling towers, and other utilities. You can use these softeners, okay, for purification. In these boilers and our cooling towers, the scaling may occur. Scaling, okay, because of the scaling, in that coil, the scales will be, stored, and the cooling capacity or the efficiency of the boiler or the cooling tower can be reduced. So we'll be using some filtration system, so that we can purify the water which is being circulated through these boilers and cooling towers. Okay, so here we can use softeners also. Then so then we have RO plant. Have you heard about RO plant? Reverse osmosis. Okay, reverse osmosis plant. This reverse osmosis is the finest water purification technology in the world. Not only now, we have UV filter, also ultraviolet filtration systems are also available in the market recently. Okay, so reverse osmosis is the finest water purification technology in the world. Water is purified by reversing the process of osmosis. So this osmosis, and we have studied in this chemistry and all those things. Biology or something. Okay. Water is purified by reversing the process of osmosis. Then membranes are used to completely remove dissolved solids, contaminants, biological and chemical impurities. Okay. So this is one of the purest form of filtration system. It is called as a reverse RO plant or reverse osmosis plant, and it can even remove 1 to 0.0001 micron, okay, of impurities from water. So where is this applicable? Okay, provides healthy and homogeneous drinking water. So we can use the water which is coming out of this RO plant for drinking purpose. So it is very pure water, and we can use it for kitchen application also. Okay, so we can use it for kitchen application also. So we have studied about uh, uh, treatment I said that we need pre-treatment, and I have already said where can we keep this filtration system. We can keep it in between the supply or the main supply from the underground or from the well, uh, and the overhead tank. In between that you can place, or after the overhead tank also you can place it. Then we have studied about different types of filters like a dual media filter. It's like softeners we have studied, and there is one like RO filter, reverse osmosis filters. Okay, these all things are helpful for purification. Not only this, we have different filters like sand filter, carbon filter, iron filter. Okay, these things are there. Then even for rainwater also we have filters. Okay, we'll be having manually. We can not manually. We can construct filters. Okay, we can construct filters by placing sands, pebbles, carbon, charcoal like that. So we can uh, you know uh, make a filter by ourselves also. Okay, by using these some materials like sand, quartz sand, activated carbon. Okay, all those things we can use it. Now, uh, I will just explain about a loop system. Like loop system is which means that just imagine this is the terrace. This is the terrace. This is the terrace, and we have an overhead or a domestic overhead tank, and as a flushing tank. So you know what is the purpose of domestic overhead tank? This domestic overhead tank, from the domestic overhead tank only you will be supplying water to the uh, you know to the toilets, where we are not giving it to except water closet. Every other areas we can give except water closet, and for gardening we can give this domestic uh, water, or we can give water from the domestic overhead tank. Correct. So this flushing overhead is used exclusively. It is used for you know flushing purpose. Flushing purpose in the sense you can use for flushing the toilet. Flushing the toilet in the sense flushing the water closet. Okay, so you can, and you can use other waters for flushing purpose. It is not necessary that it should be a pure water or a drinking water. That's why you have divided into two different tanks. Otherwise, you could have made a single tank. Why we have divided it into domestic overhead tank and flushing overhead tank? In the sense like domestic can will be the purified water. Okay, it will be more purified water. Flushing, it is not necessary that we have to purify it. Okay, because we are not using that water for drinking or bathing like that. We are just using for flushing only. So it is, if the availability of the drinking water or fresh water is very less uh, in your area, or in the location where we get a project. So for minimizing the wastage of this drinking water or a pure water, we can make two different tanks like domestic overhead tank as well as flushing tank. So we can minimize, the wastage of drinking water by just simply flushing it off. So, for example, in our house, we can construct a rainwater harvesting tank. Okay, and that rainwater can be collected in this tank, and you can use that rainwater tank water for flushing purpose. Okay, that water can be given for the flushing, or you can pump that rainwater from the rainwater tank to the flushing tank, and you can use municipal water, or the water which is from the well. If it is a pure water, you can use that for pumping to the domestic overhead tank. So the water from the domestic overhead tank we can use for drinking purpose, and for other bathing or washing your hands, etc. And the flushing, you can just exclusively we can give that water for flushing purpose, so that we can minimize the wastage of water. Okay, wastage of drinking water or pure water. Okay, now we are dealing with this looping system only. There are different methods to give water supply to the individual toilets. One among them is that it is a looping system. Looping system in the sense, if if it's a flat or if it's an apartment or a high-rise building or something like that. If there is one flat here and another flat here and another flat here, better you just do a looping system. Okay, looping system, you can see that this is the domestic overhead tank. From there, one connection is being taken and it is being circulated throughout this. It's been circulated throughout this and it will be coming back to the same tank. Okay, or same pipe itself. Okay, so you can take the water from here and you can give back to the tank or to the same pipe. The same way for the flushing also, you can just round this and when you're taking a looping system, the water will be flowing through this pipe and each area there will be water. Each area there will be water. That is why it is called as loop. So if there is a toilet here, here and here, three sides, what you have to do is that you can take one connection from this pipe. Here also you can take one connection from this pipe. Here also you can take one connection from this pipe. So you can just by the help of a loop system, you can just take one pipe from each loop. Okay, that is a very good one only. Like in the sense, if it's a 10-story building, the toilets will be in the same row. Correct? It will be in the same row. There will be a toilet like this till the ground floor. Here also it will be like that. Here also it will be like that. So for individual pipe system, if you are trying to do this looping, you can just give pipe individually. You can give pipe individually to individual toilets. Okay. This is one pipe called as looping system. If you are not doing looping system, you can take a line from here. You can give one pipe supply here. You can just take a branch from here and you can give here. You can take another branch from here. You can give like this also. So there are different methods to give water supply. Okay. Or the same way, without looping, you can just do this directly to this. Okay. From there, one connection you can take and you can give here. Then another connection you can take and give here. And we can take one connection from here and to downwards. Then we can give to the individual toilets. Now this is a very easy way for these high-rise buildings and all, like this loop system. So loop system means when you are giving a circular water connection like this, you can drop the water from any of the part of the pipe, because through all this pipe length water is being stored. So you can just drop it out from this. So the downtakes or the risers is called as telescopic downcomers or downtake. So here, this is the domestic overhead tank. This is the flushing tank. You have to take two separate pipelines from two different tanks. So through this one pipe, domestic overhead tank water or the domestic water will be flowing through this, and through this flushing water will be flowing through this, through the second pipe. Okay. So you can take one connection from the domestic water and you can give it to the wash basin and shower and all those areas. Here also you can take that. From the flushing, you can just give directly to the water faucet. Okay. So these are the domestic loop. This is flushing loop. This is the telescopic flushing downtake. This is telescopic domestic downtake. Okay. So downtake, telescopic downtake means the riser pipe. The riser pipe. Okay. Riser pipe means the vertical pipe. Okay. So this is a looping system only. Looping system. So we have to size the diameter of the loop also. Sorry, diameter of the pipe or the diameter of this loop. Okay. We have to size it. And we'll be explaining about this looping pipe size and all. Okay, we have Excel sheets and all those things, how to know the pipe diameters and all those. Okay, so we have studied about this different pre-filtration system. We studied about this looping system also. All right, and we'll be doing a question. We'll be doing a question today. Water management system is the heading. Okay, so there are some general criteria to find out the pipe sizes of this loop. Okay, we can find out the pipe sizes of this loop. Okay, uh, so if I give a question, we can find out this pipe sizes. Pipe sizes in the sense means the diameter of the domestic loop, the diameter of the flushing loop. So let me see. Let us go through a problem and see what will be the pipe diameters of this domestic loop as well as this flushing loop in for a question. Okay, so before that, you have to know something, some values. Okay, how much, how much is the peak demand, or how much liter per second is being, or the gallons per minute is being consumed by uh, different fixtures that we have to know. So before that, peak demand for residential buildings for domestic purpose. Okay, the peak demand. This is one of the method to find out the pipe, diameters, as well as we can find out the discharge also. Okay, we can find out the discharge also. Okay, so the minimum or the peak demand for residential building for domestic purpose, for wash hand basin or more wash basin, its flow is half gallons per minute. Okay, so half gallons per minute. 1 gallon is equal to 3.785 liter. Okay, so depending upon this, it says that for wash basin it is half gallons per minute is the flow. For shower also half gallons per minute. Its flow rate is being given. Okay, and some case, even if it is a rain shower and all, rain shower means you need lots of water, so it can have almost uh, you know with 7 liter 7 liter per minute. Okay, you can have 7 liter. It will go even up to 15 liter per minute. 15 liter per minute. Okay, rain shower. If it's a rain shower, the consumption might be even 15 liter, okay, per minute. Or you can call it as 3.5 gallons or something like that. Okay, so this is the normal one. Okay, normal for wash basin half gallons per minute, and shower is half gallons per minute. Tap in bathroom area is 1 gallon per minute. Okay, tap in bathroom area 1 gallon per minute. Kitchen 1 gallons per minute. This is the normal flow rates. Okay, so if for in a house, okay, or for in a toilet, if you're adding, you'll be having a peak demand of 3 gallons per minute. 1 plus 1 plus 1 3, and it says that flat having only one toilet. If it's a flat which is having only one toilet, maximum you may get 3 gallons per minute. Okay, so what is this said here is that factor of kitchen may be omitted. Factor of kitchen may be omitted from the flats having more than one toilets proportionally. Proportionately. Okay, so if it just say that if it is a toilet having only one toilet, you can take a peak demand of you know uh, gallons per minute in a toilet. If it is a residential building. Then if there is more than one toilet in a flat, so in that case you can just omit the kitchen factor. Kitchen factor. Okay. So we know what is this when we do a problem. Okay. And but the peak demand factor as generally is 75 percentage of the above. And the peak demand factor, it is a demand factor. Okay. The peak demand factor as a general practice is 75 percentage of the above. 75 percentage of the above values. Okay. So we can do a problem. So this is the question. Design the calculation of terrace loop for a building. Design the calculation of terrace loop for a building. So having 4 shops on ground. Having 4 shops on ground and 7 upper stories, having 2 flats of carpet area of 475 square feet, 2 flats of 695 square feet, 1 flat of 935 square feet, and 1 flat of 1235 square feet. having total on each floor. So design the calculation of terrace roof for a building having 4 shops on ground floor. So there are different floors are there. Okay, and there are 4 shops in the ground floor and 7 upper stories. Okay, and there are 7-story building only. 7-story building, 7 upper stories having 2 flats of carpet area. Uh, 475 square feet, 2 flats, 695 square feet, 1 flat, 35 square feet, and other 1 flat, 1235 square feet, having total on each floor. So each floor you will be having two flats of 75 square feet, 2 flats of 695 square feet, 1 flat of 935 square feet, and 1 flat of 1235. So this will be a ditto, or this will be same for all the other floors. In a single floor, it will be having this much rooms or this much flats. Okay, so it's a 7-story building only. Now, as we have seen before, the peak demand, okay, the peak domestic demand. So it says that this is also given value only. Uh, there are 2 rooms of 2 flats, 2 rooms of 475 square feet, 2 flats or 2 rooms of 695 square feet, 1 room of or 1 flat of 935 square feet, and 1 room of 1235 square feet. And it says that we have 6 toilets and 4 kitchens in each floor or per floor. Okay, per floor we have 6 toilets and 4 kitchens. 6 toilets and 4 kitchens, and we have 2 rooms of 475 square feet, 2 rooms of 695 square feet, 1 room of 935 square feet, and 1 room of 1235 square feet. So what they have asked is that we have to find the terrace looping for the building. You have to find the diameter of the terrace loop, and okay. Now, so just read this question once more, and these things are given values. Okay, discussion. This is the question, and this is also this is also given only. Okay, this red thing is also given value. So let's see how many kitchens are there and how many toilets are there in each floor. 6 toilets and 4 kitchens are there in each floor. So total there are 7 floors. Okay, so peak domestic demand. So first we are going to find out the peak domestic demand. We are going to find out what is the how much gallons per minute, or how much water that you need. Okay, we are going to see that. So first one, 4 kitchens into 7 floor, because in each floor there are 4 kitchens. So the 7th floor means 4 into 7 equal to 28 kitchens. So total 28 kitchens are there for all these 7 floors. Then 6 toilets are there. 6 toilets are there in each floor. So 6 toilets means 6 wash basins will be there, 6 showers will be there, and 6 taps will be there. Okay, and so here 4 kitchens into 7 floor is 28 kitchens, 6 wash basins into 7 floor is into 42 wash basin. 6 showers into 6 showers into 7 floors is equal to 42 showers. 6 taps into 7 floors is equal to 42 taps. Okay, so we have 28 kitchen, 42 wash basin, 42 showers, 42 taps. Because we have total 7 floor, and we have 6 toilets each with 6 as well as 4 kitchens each. So you know that from a wash basin, half gallons per minute is the demand which is coming from a single wash basin. Shower also have tap 1 and kitchen 1. Okay, so this is only for domestic. Okay, flushing will be doing separately. So we have water closet also inside the kitchen. sorry, inside the toilet. Inside the toilet, we have water closet also. So you have not seen the water closet here because the water closet will be taken separately because this water is not used for water closets. We'll be having flushing water or flush water for for water closets. So here we are dealing with wash basins, showers, and taps. These are the normal things that comes inside the uh, toilets. Correct. So let's see. So we have seen this 4 into 7 equal to 28 kitchen, 6 into 7 equal to 42 wash basin. Total we have 6 into 7 for equal to 42 showers we have. 6 into 7 is equal to 42 taps we have. Now we have to see the demand. So demand is half, half, 1, 1. Wash basin is half, shower is half, tap it is 1, kitchen it is 1. So let's do that. So kitchen it is 1, right? So total you have 28 kitchen. So how much GPM or how much domestic demand is there? 28 into 1 gallons per minute is equal to 28 GPM. The same way for wash basin it is half gallon. So 42 into half is equal to 21. For showers it is 42, 42 into half is equal to 21. Taps also you have 42 taps are there, and 1 gallon per minute is the flow. Okay, so 42 gallons per minute is the demand. Demand for the taps. So now we have to add all these things. So 28 plus 21 plus 21 plus 42, we get almost 112 GPM. 112 GPM is the peak demand. Understood what I'm saying? 112 GPM is the peak demand. This much gallons per minute is needed. Okay. Now another one thing that we have to know is the simultaneous demand factor. So this is the peak demand, which means that all the showers, wash basins, and kitchens, everything is being used in a single time or in a peak time, or all these are in use simultaneously. All these showers and wash basins and taps, everything is in use. That is called as the peak demand. Okay, the peak demand. So more water is needed. So always, or it's a rare case. It won't happen. Correct? All the wash basins, showers, taps, kitchens, everything you want open. It is a rare case. Correct? So even though this is the 112 gallons per minute is the peak demand, in a practical sense, this is not always that is this won't happen. This won't happen. The peak demand won't happen. So there is a factor called a simultaneous demand factor. So we have already seen what the simultaneous demand factor is that, but the peak demand factor as general practice is 75% of the above. Okay, so it is the 75% of the above. We are not taking the peak demand because that is not practical. Practical in the sense that won't come. Correct. So simultaneous demand factor is we have to multiply with the demand factor. Okay, that is 0.75, 75%. So just multiply with 75%, you will be getting 84. So 84 is the demand. Okay, water demand, and the peak demand is 112. Okay, even though this 112 GPM is not required because we won't use all the wash basin, showers, taps, kitchens at a time. So we have to multiply the peak demand with a simultaneous demand factor. Okay, and which means that it's a 75%. Okay, so multiply with 75%, 0.75. You will get 0.75 into 112 is equal to 84 gallons per minute. So in order to convert this gallons per minute to gallons per hour, you just multiply with 60 minutes. Okay, so 1 hour is equal to 60 minutes. So you just multiply, and let's see, you will be getting 5040. You get 5040. 84 into 60, how much? Yes, 5040. So 5040 gallons per hour is our demand. Okay, 5040 gallons per hour is our demand. So Q is equal to peak demand in cubic seconds or cubic feet per seconds. Okay. Q. So we have to find the discharge. Okay. So we have already found out the discharge as 5,040 gallons per hour is the peak demand. Okay, peak demand. Okay, after multiplying with the simultaneous demand factor. So this much water we need per hour. Okay, this much water is in demand. We need it is in demand. Okay, this much water that we need for this particular project. Okay, or for this particular question, we need 5,040 gallons per hour. Okay, now that is Q. Okay, so Q. So now we can just consider two outlets from the tank. Okay, you can give a single outlet from the tank, or as well as we can give two outlets from the tank, which means two discharges from the tank. Okay, so if you are considering two outlets, so you can give one outlet or two outlets according to your need. So if we are in this question, if you are considering two outlets from the tank, the peak demand per outlet will be So if you are trying to take two outlets from this tank, considering two outlets from the tank, peak demand per outlet will be 5,040 divided by 2, because we are dividing it into two. Because two outlets, we are taking the water from the tank from the two outlets. So 5,040 divided by 2 is equal to 2,520 gallons per hour outlet. So from two of the outlet, it will be 5,040. From a single outlet, it will be 2,520. Okay. So therefore, in order to find out the value in cubic seconds or cubic feet per seconds, you have to multiply with a constant 22,500. So this gallons per hour, you divide by 22,500, you will be getting the answer in cubic seconds. You will be getting the answer in cubic seconds. So this much is the cubic seconds. This much water you need from this much water is being demanded from one outlet. Okay. So we have a tank, and the water requirement is 5,040. So we consider two outlets from the tank. So from one outlet, 5,040 divided by 2 is equal to 2,520 gallons per hour per outlet. So which means if you are converting it into cubic seconds, it will be 0.112 cubic seconds from each outlet, or per outlet 0.112 cubic seconds has to be flowed, or has to be discharged. Okay. Now another important, so you got the domestic. So we are focusing on domestic only. We have flushing also, that is also coming. So here we have domestic only. Okay. So in this case, in this domestic, we got from one outlet, we got 0.112 cubic seconds. Now coming to the flushing, peak demand for flushing. So here we have peak demand for domestic, peak domestic demand and peak flushing demand. So we have to take these two separately, and we have two different separate tank also will be there. One for the domestic purpose and another for the flushing purpose. Correct? So for the domestic purpose, we have found 0.112 cubic seconds from each outlet. There are two outlets. From each outlet, you got 0.112 cubic seconds. Now coming to the we are focusing on peak demand for flushing. Okay, so it is said that assuming 6 flushes per hour, so we have to flush it, right? So we are assuming that in 1 hour, we are assuming that we will use 6 flushes. Okay, 6 flushing is being done in 1 hour. Okay, and imagine that at each flush it consumes 2 gallons. Okay, so each flush it consumes 2 gallons of water. So assuming 6 flushes in 1 hour, what will be the total gallons in an hour? 6 flushes we are assuming. 2 gallons will be will be flushed out in 1 flush. So 6 flushes means 6 into 2, 12 gallons. So 12 gallons of water will be flushed out in 1 hour. Okay, that is the peak demand for flushing. That is a peak demand. Okay, so we got 12 gallons per hour. Okay, and this has uh, uh, 2520 gallons per hour per outlet, and this also 12 gallons per hour from flushing tank. Okay, this is from domestic tank. Now, we are see, this is the domestic tank and this is the flushing tank, and this is the pipe. This is the pipe. One is the domestic loop as well as the other one is flushing pipe or flushing loop. Okay, so for example, you can just imagine that this length is 400 feet. Okay, 400 feet. So you can measure it, right? You can measure it in your project. So always it won't be 400, it can be 500 or it can be 200 or it can be how much, it depends. Correct. So for example, as we are dealing with a problem, uh, let length of the loop, we just say for example 400, the length of the loop. Okay, we are now dealing with domestic only. Okay, domestic loop only. We are trying to find the diameter of the domestic loop only. So just imagine that the length of the domestic loop, let it be 400 feet. So to the one side. Okay. So the length per outlet. So just imagine one outlet is being taken to this and another outlet is being taken to this. Okay. That is the two outlet. Okay. One outlet it will be taken and fixing there, and another outlet it will be taken and fixing there. Okay. So the total length will be, for example, imagine there is a two outlet. One outlet will be coming here, and another outlet also will be taken here, and it will be coming at this. Both the outlet will be joining. Okay. Let this total length be 400. So from each outlet, what will be the length? You can take 200 feet. Correct. So therefore, length per outlet 400 by 2 is equal to 200 feet. Now H is the effective head. So effective head means half of the height of the tank. Half of the height of the tank plus the distance from the terrace slab to the bottom of the tank. So you know that the water tank won't be kept on the terrace. It will be kept in an elevated position only. So there will be a terrace and there will be an overhead tank which will be in a stand or something like that. So in order to find the effective head, you have to multiply into half into the height of the tank. There will be a height in the tank, right? There will be a tank. You have to multiply with the height of the tank, plus you have to add distance from the slab or distance from the terrace slab to the bottom of the tank. So you need to know what is the height of the tank. Okay, and you need to know the at which height the tank is being placed. That's what it means. At which height the tank is being placed, which means that the distance from the terrace to the bottom of the tank plus the height of the tank plus the half into the height of the tank. So just imagine the height of the tank is 4 feet and the distance from the terrace slab to the bottom of the tank will be 6 feet. So half into 4 equal to 2, 6 plus 2 is equal to 8 feet. That the effective head be 8 feet. It will be differing, okay, according to our questions, okay, or according to our applications and the site conditions. This head will be changing, okay. This H as well as this L will be changing. For the time being of this question, we got H as 8 feet and L as 200 feet. Now this is a table. This is the K value and this is the diameter. So depending upon the K value, we can find out the diameter of the loop. Okay, depending upon the K value, we can find the diameter of the loop. Okay, so this many it is given as 8076. It is half inch dia, 1063354 inch. So when the K value reduces, the size of the pipe increases, or the size of the loop pipe, the size of the pipe, okay, will increase if the K value decreases. So now we will be working out the K value for the dia of the terrace loop. Okay, the same can be converted into actual dia in inches by referring to table 1. So this is the table 1. So in order to find the K value, we have the formula K is equal to H divided by Q into L. This H is the effective head, Q is the discharge, and L is the length. So you know all these values, correct? H means effective head. Effective head is 8 feet. Now Q is the discharge. Discharge how much? Now we are dealing with not the flushing. We are dealing with domestic only. Okay, domestic water only. Domestic water and domestic loop. So our discharge Q is equal to how much? 0.112. So 0.112 into 0.112 into length. How much is the length? Length we have to take as 200 only. Okay, don't take 400 because we have two outlets. Okay, so you can take 200. 200 as the length. So why you have taken 200 as the length means there are two outlets. If it was a single outlet, you would have taken 400. Because it is a two outlet, you have to take 200 only. Because for one outlet, the length is 200. So we are finding out the diameter of that one pipe only. The other pipe also will be same. So the length won't be 400, the length will be 200. Okay. So yeah. So 8 divided by 0.112 into 0.112 into 200. So 8 divided by 2.5 will be getting almost 3.1888 as the K value. So 3.1888 as the K value. So you can just see the K value and its diameter. It's a related diameter. You can see it is 3.118. So it is coming between 7.88 as well as 2.58. If it is going below that, it is coming to 1.034. So if you are taking with respect to 3.1, if you are going for 1.0, it is 3 inch. It is going above 2.58. Above 2.58. So it is coming closer to 2.58. So between 7.88 and 2.58, we have 3.1. So you have 2 inch dia as well as 2.5 inch dia. Okay. So if you take 7.88, the diameter will be very less because 3.1 is coming closer to this 2.58 value. Okay. So as a safe method, we can go for the higher value, 2.5 inch. So therefore, on the safer side, 2.5 inch dia terrace roof will be ideal. So this is the way to find out the diameter. Okay, this is the way to find out the diameter of the loop. Diameter of the loop. We need to find the discharge. Okay, by the formula like the mat. Okay, so how much water that you need. Then what we do, we need to know what is the effective height. We need to know what is the length. Okay. From that, we can find out the K value. From K value, we can just choose the appropriate diameter. So here we can take 2.5 inch. So here we can take 2.5 inch as the 2.5 inch as the pipe diameter. 2.5 inch as the pipe diameter. Okay, which pipe diameter? Domestic loop. Okay, not flushing, domestic loop. Now, same way you have to find out the flushing loop also. So how to find out the flushing loop? So flushing terrace loop, the Q that we got is how much? How can we find out the Q? Q is the to find out Q is equal to number of toilets into 12 gallons per hour. 12 gallons. How you got 12 gallons? You got 12 gallons because it is assumed that 6 flushes in 1 hour. It is assumed that we are needing 6 flushes in 1 hour. And in one flush, it consumes 12 gallons. So, which means that from one water closet or from one toilet, 12 gallons per hour is being consumed in 1 hour. Okay, 12 gallons is being consumed in 1 hour from one toilet. Correct? From one toilet, because from one toilet we are giving 6 flushes in 1 hour, and 2 gallons is being wasted or it is being used from one flush itself. So the total flush will be 12 gallons per hour. Okay, from one toilet. So how many toilets are there? So here we know that there are 6 toilets in each floor. 6 toilets are there in each floor. So how many floors are there total? 7 floors are there. So total toilets will be 7 into 6. Will be how much? 42. 6 6 are 36, 6 7 are 42. So 42 toilets are there. From one toilet, 12 gallons per hour is being consumed, or that is the peak demand for flushing. So for 42 toilets, how much gallons per hour will be consumed? How much? So 42 into 12 equal to 504. 504 gallons per hour. So in order to convert it to cubic seconds, divide by 2250, you will be getting 0.0224 cubic seconds. Now by using this same formula, A is into H divided by Q into Q into L, now we can just the height of the tank will be same. Uh, that the effective H will be how much? 8 feet, leave it there. And the Q will be different. Q will be how much? 0.224. So 0.224 to 0.24 into 200. Length is 200. So we'll be getting 79.7194 is the K value. 79. 79. So 7.8, 83. Yeah, 79 is coming very close to 82.69. So better we can take 1 by 4 inch. Okay, 1 by 4 inch would be ideal. Okay, so here this says us 1 by 2. So you can take this. This is just going at, below this 82 only, 79. So for a safer side, if you are using 1 by 2 also, it is safe because the pipe size is increasing. Correct, but but 1 by 4 will be enough. Okay, but 1 by 4 would be uh, enough because it is coming closer to 82 only, but still it is coming towards 33 only, right? 79 is coming below 82 only. So if you are choosing 1 by 2 or 1 by 4, it would be, you can choose this board, but for a safer side, if you are choosing 1 by 2, that would be better. Okay, so you can choose 1 by 2 or 1 by 4, but if you are choosing both, also not a problem. But 1 by 2, we can choose as a safer side. You can choose as a safer side. So this is the way that we will be finding out the terrace loop. So in order we can find out the terrace loop for flushing as well as for domestic purpose. We can find it. Okay, and we need to know the head, the height, effective height or effective head. Then we need to know the length of the loop. Then we need to know the discharge, how much water is being discharged, the total discharge. Okay, the total discharge for individual fixtures. Okay, when we know that value, go and substitute in the equation, and you will be getting the value. That value you have to verify with this, and you will be getting the proper diameter. Okay. So today we have dealt with the water management system, and we have seen about different uh, purification systems, like we have seen RO filter, different softeners, and dual media filters are there. Then we have explained about a little bit about the sand filter, carbon filter, iron filter, like that. Okay, and we saw that where can we keep this filtering system. Okay, and then after that we have seen about the terrace looping. Okay, terrace looping. So high-rise buildings, if you are living terrace looping, that will be fine. Okay, so usually you can take different downcomers from points of that loop. Okay, otherwise we have to run the different pipes, individual pipes to different toilets. Individual. Here, if you are having a loop, pipe loop, from there you can directly take one line from that point. Correct. So here we have studied about the domestic pipe looping as well as the flushing pipe looping, and we have found out the diameter by using this formula. Okay. So there any doubt in today's class? Is there any doubt? Is there any doubt? Did you get all other video links to you? I'm sending the video links each day. Are you receiving the video links? So is there any doubt? Is there any doubt? Just give me a chat, okay? No means we can wind up our class, today's class. Any doubts? Water management system. So if there is no doubt, means we can wind up our class. So see you tomorrow. Okay. So thank you.